Hello everyone. Welcome to this session on assessment of bridges as per CS 454. I am Anuj Asati from MIDAS IT. So CS 454 is the new standard for the assessment of highway bridges. In this session, we are going to learn more about this code and how it is implemented in MIDAS Civil for assessment of structures. A little bit about myself. So hi, I am Anuj Asati. Currently, I am working as a senior structural engineer at MIDAS IT. I have been working in bridge engineering field for past 5 years, and before joining MIDAS I worked as a design engineer for Larsen and Toubro. Here I was a part of a design team that worked on a railway project called Dedicated Freight Corridor DFCC. Now in MIDAS I am part of UK support team where we provide technical support to engineers and help them solve their problems. So this was about me. Now let's move towards the session. Now the contents of the session are as follows. So first we will have a brief introduction to CS 454 standards. We will also have a look into live loads that need to be considered for assessment. Then I would like to shed some light on how CS 454 has been implemented in MIDAS Civil for assessment of bridges. So let's start with introduction to CS 454. So before going to CS 454, let's answer a very basic question. What is the need for assessment of bridges? So the basic purpose behind this is bridge assessment provides a measure of adequacy of an existing bridge or a new bridge for that matter for the current design loads. And environmental conditions and repetitive loading can reduce the expected lifespan of road bridge. So this is when bridge assessment comes into picture, and a load rating is the key tool for assessment. So load rating are expressed as rating factor for a particular vehicle, and the emphasis in load rating is on the live load capacity and the approach to determine the rating factor, instead the design approach of satisfying limit states. And load rating for bridges is done at both strength as well as service limit state. So with the understanding of bridge assessment, let's move on to CS 454. So CS 454 is the new standard, as I mentioned, used for assessment of highway structures. Though this document the structural safety and serviceability of highway bridges and structures can be assessed, it also provides a key information that is required to manage the risk and maintain a safe and operational network. So the first version of CS454 was released in June 2019, sorry, and revision 1 was released in March 2020. So this standard supersedes BD 21/01, BD 16/97, and BD 37. It includes wind, thermal, HA and HB load models in new appendices. Previously, these were available in BD 37. A small modification in traffic load model for loaded length greater than 50, which was previously in BD 50, is now included in CS 454. Also, increase in lane width for all Model 1 with CS 454, additional standards such as CS 455, CS 458 are also released, which will be used altogether for assessment of bridges. So CS 458 is for special vehicles, SDGO and SO, and this replaces BD 86/11. And CS 455 is for assessment of concrete bridges, which replaces BD 44/15, BD 38/93, and the other codes mentioned here. So with all these changes, MIDAS Civil has newly implemented these standards for assessment of structures. Now let's move on. Now the assessment process is shown as in the chart in the screen. So in a practical project, one will start with the structural review, then inspection of assessment, and then perform the real assessment, and then work on reporting of assessment. So here in MIDAS Civil, we will mostly focus on assessment, and the implementations which has been done are related to the assessment of structure, as well as the results that we get from assessment will help you for reporting of assessment as well. And once reporting of assessment is done, then management of substandard structures is done. That can be done by strengthening or replacement, and this will further lead to periodic inspection and maintenance, which completes one cycle of assessment, and this will go on again and again. Okay, so the point is here we are mostly going to focus on assessment of structure and the results which will be used for reporting of assessment. Now coming to the assessment live load and levels of assessment. So the characteristic action for traffic loading on carriageway shall be defined for assessment using an assessment live loading model. And this represents the level of traffic to be assessed, the influence of the road surface category on the impact effects of vehicle, the influence of traffic flow category on the likelihood of vehicle overloading, and lateral bunching. So as far as the level of traffic is concerned, we have three levels of traffic: normal, restricted, and abnormal traffic. So for normal traffic, all model 1 and ALL model 2 should be considered. However, for restricted traffic, all model 1 with weights as 26, axle weight as 26, 18, 7.5 and 3 ton to be considered. And for abnormal traffic, STGO and SO vehicles should be considered, as well as HB load models. So all these vehicles which we have discussed are implemented in MIDAS Civil. However, we would like to focus on the new new vehicles which are implemented here, which is all model 1 and 2. Engineer also need to decide the level of assessment. Level 1 would be common type simple structural analysis methods, and these gives conservative assumptions for material properties, whereas level 2 has a refined structural analysis method, including non-linear or plastic analysis method. And level 3 commands use of material properties derived from testing samples of the structure, or use of bridge specific assessment live load models derived from measurement of loading data. So for purpose of this session, we will be focusing on level 1, which is simple structural analysis methods, which leads to a conservative assumption of material property. Finally, we need to go for assessment verification by comparing assessment action effect with assessment resistance effect. So here SA star signifies the assessment action effect, and RA star signifies the assessment resistance. The assessment resistance is function of condition factor and characteristic strength, characteristic nominal or worst credible strength of material, and partial factor for material strength. This has to be calculated from CS455 for concrete structures. Then coming to the assessment action effect. This is a function of SA star is a function of gamma F3 and effects of QA star, which is the assessment action. So gamma F3 is partial factor for load effects, and assessment action is nothing but gamma FL into QK, and gamma FL is here partial factor for load. Okay, so based on this equation we will find we will do the assessment of our structure and find adequacy factor as well as psi and psi star, that we will look in further detail in the coming slides. So a typical assessment report comprises of first the introduction, then a structural description, then if any previous assessment has been done on the structure, then the summary of those as well as dates. Then based on those assessment, if any interim measures were taken, for that the summary and dates need to be mentioned. Then monitoring summary with dates in accordance to CS 470, and then assessment inspection summary, and then assessment methodology, assessment commentary, and then assessment results. So here in MIDAS Civil we will be focusing on this 9th point, and whatever results we are getting from the assessment which we perform in MIDAS Civil will help us to create to fill out this particular section of our assessment report. So here in addition to giving the overall assessment capacity of the structure, data should be presented about those elements that were critical in assessment failure. Okay, so what are things that we have to that we need to provide here is first the critical element identity and value of appropriate assessment load effects. So here SA star is a special load effect due to special vehicle, SD is a load effect due to dead load, and S star HA is load effect due to standard vehicle, and S star is sum of all these three. Then a value of assessment resistance, which is RA star. So all those things we will get here. Then we need to provide the adequacy factor, which is RA star by SA star, or reserve factors psi SV and psi SV star, and then vehicle rating. Then once this section is completed, then we'll move on to recommendations and then assessment synopsis. So with MIDAS Civil we will be able to get results which will help us to fill out this section. Now regarding the equation for adequacy factor and reserve factor, so that can be, so the adequacy factor equation is RA star by SA star, which is the ratio of the assessment resistance and the load effect. Then psi is the special vehicle reserve factor with standard vehicle, and psi star is special vehicle reserve factor without standard vehicle. So all the equations are given here, where SD star is the assessment load effect due to combined dead load and superimposed load, and SST star is the assessment load effect due to associated type standard vehicle with loading. Then S star is the assessment load effect due to special vehicle load model, and S star A is the total assessment combination effect. Okay, now let's move on to consideration of live loads for assessment. So here we will discuss what live load should be considered for assessment of our bridge structure. Now for the assessment, so normal traffic load vehicle is classified in two in CS 454, all model 1 and all model 2. Either of these two models can be used. Uh, Either of these two models can be used for assessment of bridge. And usually we expect all model 2 to generate uh, more critical effect on the structure. But if the engineer feels all model 1s give more critical effect, then all model 1 can be used for assessment. So MIDAS Civil gives a liberty to select any of the load model for assessment of bridge. So regarding all model 1, so here all model 1 is can be we can go for a single vehicle in each lane, or we can go for a convoy of vehicle in each lane as well. And the factors that we need to consider are: first, an impact factor applied to most critical axle obtained from table 5.1, which can be seen here. So here we have that factor for single lane vehicle as well as for convoy, and depending on the surface, is it a good surface or a poor surface. Then second is a traffic flow factor. So this we can get from this 5.9 B table from CS454. Here, based on high, medium or low, we can get the traffic flow factor. Then a lane factor for table 5.9C. So here based on L1, lane 1, lane 2, lane 3 and lane 4 and subsequent lanes, the factors are given here. So how in MIDAS Civil, the most critical lane is considered as lane 1, and then the subsequent lanes are decided. So here this is the definition for moving load case for CS45, a definition of all model 1 in CS454. So here you can see, using this loading case, we can select single or convoy, and based on that the impact factors will be considered. And here we can select road surface, and based on that this the impact factor for a critical axle can be considered. And then based on the traffic flow, this high, medium and low traffic flow factors will be considered. And based on the number of lanes defined, as well as on what lanes loads are applied, based on that, whichever is having most critical effect will be considered as lane 1, and lane which has a less critical effect than lane 1 will be lane 2, and so on. So this is how these factors are considered for all model 1 in MIDAS Civil. Then in Appendix B has all the details for different vehicles, including normal traffic and restricted traffic. So here we have details regarding normal traffic, and this is for restricted traffic. And here from the drop down in all model 1 vehicle definition, we can select any of these vehicles as needed. So we can select any of these vehicles and create any of the effect either for normal traffic or for restricted traffic. Now coming to all model 2. So all model 2 consists of a combination of uniform and knife edge load and a single axle load. So single axle load is not implemented in MIDAS Civil. It would be used usually, the single axle load is used in the local model for verification of the deck, and however we are going for global model, so we expect that it will not generally affect the global bridge model. So hence we go for a combined uniform and knife edge load. So here is the definition for the knife edge load given in the code. So based on your loaded length, the UDL and knife edge load need to be considered, as well as the lane factors to be considered here as shown here. That is also dependent on the loaded lane. Okay, and then the category factor for K, this depends on the traffic, loaded length, and for depend on what is the traffic category as well as what is the surface category. So if the surface is like a high traffic poor surface, So this is the variation of K shown for loaded length, and based on this the K factor need to be considered. So here to consider all so the based on the program will find a loaded length, and based on that the uniform UDL and knife edge load will be calculated, as well as the factor K factor will be arrived at based on the traffic surface category selected here, as well as the load level. Okay, so now moving on. Now we have seen there are three partial factors: gamma 3, gamma L3, gamma FL need to be considered. So partial factor for actions gamma FL is automatically applied in moving load results. So here when we are defining a moving load case, so here we will select the code according to which we want to perform the moving load analysis, as well as we will define whether it is a ultimate limit state or serviceability limit state, and the combination, what combination we are going for. So regarding gamma FL, the partial factor for action effect that need to be considered for moving load as shown in the table here need to be differently applied for ULS and SLS case. As you can see here uh, for uh, so for ULS, so this is for ULS case and this is for SLS case. These partial factors are automatically considered. So here they depend on either ULS, SLS, and they also depend on the type of combination. If it is a combination is 1 or combination is 2, 3 type. So based on that also this factor depends. However, these partial factors gamma FL is automatically considered for moving load analysis depending on type of combination and type of case, either ULS or SLS selected in moving load case definition. Okay, so we don't need to consider it again. Now coming to assessment verification in MIDAS Civil. So to perform assessment in MIDAS Civil, first we need to define the partial factor safety for materials. So that can be done by going to rating. In rating we can go to this PSC bridge. So here we can select CS454 first, and then here we have an option of assessment code parameters. So in this we can first define FC, the condition factor, and then we can define the material strength used for assessment. So here we can go for characteristic strength, or we can go for worst credible strength. Then coming to design parameters, the partial safety factors for material. So we can, by clicking on this, we can define this partial safety factor. So either we can update it by code, so that will be done as per CS455, or we can manually input these values as well. Then we can define what are the outputs we are expecting. So here we can select flexural, shear and torsion. So the the rating factors will be calculated for flexural, shear and torsion. Okay, and then for serviceability limit state we will get for stress and stress check will be performed. And detailed report do we want for ultimate and serviceability, so we can check on those. Then once the partial safety factors are defined, then we can define the rebar and material properties for assessment. So whatever reinforcement we have defined will be considered for assessment resistance calculation of the section. So here by going to section manager and reinforcement, here we can define a reinforcement for part 1 as well as for part 2, part 1 being the girder and part 2 being the slab. Okay, and then we can modify a material which is assigned to the girder with material properties of rebar for girder and material properties of slab and rebar for slab. Okay, we can update that. So those material properties will be used for assessment purpose. Then define load combinations. So to define the load combinations, we need to go to load combination for assessment. So here we can just name it and we can select what type of load combination is it. Is it a ULS or SLS type of load combination? And then here we need to define gamma F3 which we have seen earlier for our load effect. Then here we have to define gamma FL, partial factor for load, and this is partial factor for load effect. So here we will define whatever loads we want to consider for our assessment. Then here we need to define the moving load case that we need to consider for this particular load combination. And as I have mentioned earlier, here we don't need to define the gamma FL, as it will be automatically considered as per the code, as per the type of combination, which is combination 1, 2 or 3, and then type of either it is ULS or SLS. So based on that, the gamma FL will be automatically considered for moving load. So this is how we can define the load combinations for assessment. Then if you want to consider the same combination which we have defined for assessment for to do a stress check in the normal analysis, then we can copy this into copy into general load combination. By pressing on this, it will be copied to general load combination in civil. However, if you want to copy itself in assessment load combination itself, then we can use this upper option and it will create a copy of that particular load combination in program itself. Then moving on to definition of section for assessment check and report. So here we can select the sections for which we want to perform the assessment check, as well as for which we want to generate the report. So it is as the assessment calculation takes a little bit time, as well as report generation takes time, it is recommended to go for only critical sections for performing of assessment as well as for report generation. As if we select all the members, it will take a lot of, it will be quite time consuming, and it will not, like, it will be the computational power, it will require more computational power from system. So here it is recommended to go for only critical sections for which we want to perform the assessments. Then here we need to select which position we want to perform the assessment, IJ or IJ, IJ or INJ both. Then we have to select the class category. So this class category is based on the stress limit as per CS455, then based BD 4415. So here we need to, based on what is the limit of stress for non-composite, composite and tension, we need to select this. So earlier class 3 was not implemented in MIDAS Civil, but now in latest version this has also been implemented now. Now suppose if I select class 1, so here this will be the stress limit for my non-composite composite section, and no tension will be allowed in my section. Now once we with this, the definition of assessment is complete in the program. Now we can perform our assessment by clicking this perform assessment icon, and once we do that, assessment results will be available in tabular format as well as in Excel report format. So here we have this Excel report generation option, and this is tabular format of results. So then the first thing we have, the first result that we can see is the flexural reserve factor table. So here you can see in the tabular format we will get this reserve factor table. So and here this is the result in the report, Excel report, which is generated. Now here the flexural resistance here is calculated based on the short-term assessment stress strain curve for concrete, which is given in CS454, and yeah, based on that, these calculations are performed, and the output which we get is resistance, assessment resistance. Then here this is the load effect due to special vehicle, and this is load effect due to dead load, and here this is load effect due to standard vehicle, and this is summation of all. And A stands for adequacy factor, and this is the flexural reserve factor, psi and psi star, and this is the check. So if the uh, adequacy factor and psi factors are greater than 1, then this check is okay, or else if it is not passing, that will be NG, not good. Okay, so this was for assessment verification MIDAS civil for flexural. Similarly, assessment verification for shear can also be seen. So first, for shear, the program checks if the section is cracked for flexure, and if it is cracked or uncracked. Based on that, the capacity, shear capacity, shear resistance of concrete is calculated, and it also verifies if shear link is effective. So if it is effective, then it will calculate Vs, and if it is not, then shear reinforcement will be ignored, and shear strength, shear resistance is calculated, Vu, which is summation of concrete resistance plus shear rebar resistance. Okay, and based on that, where maximum shear is, we verify the maximum shear. So this is the work, this is the flow for checking of shear reserve factor, and these factors similar to how we saw for flexural reserve factor, similar way these factors are also calculated. Then moving on to torsional resistance. So for open sections like I section or T section, composite I section, composite T section, this torsion verification is skipped. So it is only for box PSC box girder or U-type composite girders. And here the stress due to torsion is verified, and then it is checked if torsion rebar is needed or not, and then based on that shear stress due to torsion is calculated, and then uh, we verify the torsional stresses. Okay, so this is how the torsional reserve factor is done. Then last but not least, the serviceability limit state verification table. So here stress check is performed based on the stress limits which we have defined based on the selection which we have done for class 1, class 2, class 3 section. Based on that, the stress limit check is done. Okay, and then we also get the MS Excel report, detailed report with all the checks performed will be shown here. So once we perform the assessment in software, I will show you how this report is generated. Okay, so now let's take you to the assessment, how we can perform the assessment in MIDAS Civil. Okay, so here we have this single span PSC I girder bridge. So here we have 5 I girders, and we have gone for Y8 UK Y8 composite beam here, and you can see we have done a construction stage analysis. So here in stage 1 only my longitudinal girders are activated, and then in stage 2 the wet concrete load is applied, and then in stage 3 the sections become composite, and then stage 4 is a long-term stage. Okay, so yeah, we have also defined reinforcement for our composite girder. So if I select here, so here you can see the reinforcement for the composite girder can be seen here. So yeah, so these are the reinforcement. So so we can now, this reinforcement will be used in calculation of assessment resistance of the section. Okay, so Now I will turn on this hidden option. So now let's define moving load for assessment for our bridge. So to do that, first we need to go to load, and in load we need to go to moving load. Here I will select BS code. So I need to go to base stage. Now I will select BS code. Here I will undisplay the loads that are applied. Okay. Now I will define first the traffic line lanes. The total carriageway width for my bridge is 9 meters, so I will define 3 lanes. So first will be lane 1, and here eccentricity will be minus 1500 mm, and distribution will be cross beam type. So I will select cross beam, and then I will select the first and last node for which I want to create my lane. So here this creates my first lane. Similarly, now the eccentricity will be 4.5 meters or 4500 mm. This will remain same. Name will be lane 2. The first and last node. Apply. Then create the last lane, which will be lane 3. Here eccentricity will be 7500 mm. Okay. Okay, so these are the 3 lanes which we will be needing for our assessment. Now we will define the vehicle, assessment vehicle for our bridge. Okay, so first I will go to add standard. So here from the drop down we will select CS454 assessment. Now here I can go for all model 1 or all model 2 UDL plus knife edge load. So first let's define one all model 1 load case, and here I can go for different vehicles which are available for normal and restricted traffic. So and then here I can select it based on it is single on convoy and the surface road surface depending on good or poor, and what is the traffic flow category. Similarly, I will define one all model 2. So here based on the loaded length, the UDL and knife edge load will be calculated, and K factor will be calculated on traffic surface category and load level. Okay. Then I will need one special vehicle. So for that I will select CS458, which was earlier BD86/11. So here I can select various special vehicles. So for now I will select SV80. Okay. So now these 3 vehicles I will be using for my moving load definition. So I will define a moving load case. So for that I will click on moving load case. Here I will go to add. So load case name, first load case name be MLC1, sorry ULS. Okay, and this will be for all model 2. Okay, so here I will select, do I want all model 1 special vehicle, all model 2 special vehicle. So first when I am defining for all model 2, so here I will select all model 2 and special vehicle, and I will go for auto live load combination, and type of design combination factor. First we are defining for ULS and combination 1. Here I will select my all 3 lanes, and for straddling effect I will select lane 1, 2 and lane 2, 3. Now I will apply. Okay, similarly I will create one more for SLS. Now here I will select serviceability. Rest of the things will remain same. Now I will define for all model 1 as well. So here this time it will be all model 1 and it will be ULS combination 1. Rest of the things will be remain same. Then it will be SLS, the serviceability, then OK. Okay, so these are the four combinations which we have considered for assessment. Here we have gone for both load model 1, all model 1 and all model 2. Then we have defined the assessment moving load. Then we will move on to rating. Here we will go for CS45420. Then here I can go for assessment code parameters. So first I can define here the condition factor as well as material strength used for assessment. So I can go for characteristic strength or worst credible strength, and then partial factors I can go by CS455 code, or I can go for user defined as well. Okay, and these are the outputs that I want. Then coming to load combinations, so here let's define first load combination for ULS. Okay, and here gamma F3 we can define as 1.1. Now let's define first load as dead load. Factor will be 1.1. Then we can define S ideal. So here factor will be 1.75. Then last here we can define is tendon secondary. Factor again will be 1.1. For moving load, so here I can define one ULS for all model 1 and one for all model 2. For now I am only going for all model 2. So here I will select ULS all model 2, and here we don't need to define any gamma FL, as I've told you earlier. It will be automatically calculated by the program. Now here I can go for SLS. Okay, so gamma F3 will be 1. Here we will have dead load, S ideal, tendon primary, and tendon secondary. Okay, and here we have SLS all model 2. Okay, so these are the two combinations. Similarly, two more combinations can be considered for all model 1 vehicle. Okay, so now I will close this. Then now I have to we have defined the load combinations here. Now it's time for us to select the sections for assessment. So here I will select IJ both, and I am going to select my second longitudinal girders. Okay, so I will press apply. Now coming to report generation, here I will select element number 33 and 34. So this is element number 33, 34. Then I will apply. So now my elements are selected for assessment report. Okay, now we are ready to perform the analysis and then perform the assessment for our bridge. So analysis and assessment performing of analysis and assessment will take a little bit of time. So for that I have already performed the analysis and assessment for a similar model, exactly same model actually, and then now we will discuss the result for those. So for this model we have already performed assessment and analysis and assessment. I will just display. So here this is the bridge. Now let's see results for moving load. So for that we will go to beam diagram. So let's see MV Max ULS all model 2 moving load. I will turn on the legends and in kilonewton meter. So we are getting a maximum moment of 2400 and we are getting it around at element number 13. Okay, so now let's select now let's see the vehicle position for that. Now I will go to element number 13, apply. Now you can see on lane 1 special vehicle has been applied SV80, and then on the other two lanes all model 2 vehicle has been applied. Now we can convert this result into static and we can use them further, and we can also see same result in tabular format as well. So for that I will go to beam forces, and here we have ULS MV max. Okay, these are the maximum moment. So now here we can go by load case my. Now here what we will get, the moving load results segregated for standard vehicle and special vehicle. So we will be using, so when we calculate the psi factor, for psi factor and psi star factor, we will be needing the effect, load effect due to standard vehicle and load effect due to special vehicle. So using this we can calculate the psi factor quite easily. Here we have already performed the assessment as well. So I will go to rating. Here we will go to assessment, reserve table. So here you can see this is the calculation of psi factor, psi star, adequacy factor, reserve assessment resistance, and load effect due to special vehicle, load effect due to dead load, load effect due to standard vehicle, total load effect. Okay, and adequacy ratio of load effect and resistance to load effect. So like this, this is for flexural. Similarly we'll get for shear, then we can get similarly for torsion. So torsion, as this is an open section, so this check will be will not be done. Then SLS. So here for these section the SLS check has not passed, so that's why it is NG. So it is marginally, it is less than 1. So whenever a particular section does not pass, it will show in red and NG, which means not good. We have also generated the report, assessment report, which we are going to look at now. Yeah, this is the assessment report which we done. So here you can see the design condition first, then assessment factor calculation, then flexural reserve factor, shear reserve factor. So this is for element number 33, torsion reserve factor and serviceability limit state reserve factor. And then for element 33 I, so this is the details of how those reserve factors are calculated. So here on the top you see as the design condition and section properties, partial factor of safety which is used, material pre-stressing information, then flexural design of section. Okay, and this is the iterative calculation for neutral axis. And then here we go for the flexural resistance calculation. Similarly, shear design of section, first crack check is done, then based on that the further checks are done. Then we have the torsional design. So yeah, this was so now you can see this is failing in the serviceability limit state check. So this is how the assessment can be performed in MIDAS Civil. So now if you have any question answers, we can discuss. Thank you all for attending this session. So if you have any questions, just let us know. We'll be answering those questions now.